Okay, hello. So in this video, there's two extra examples of doing limits from graphs and from formulas. I'm trying to do the first principles idea of a limit. The idea of a limit is getting really close to something. So here's exercise 179. You have some graph of the function f of x. It's a funny looking graph. And you want to do these two limits. The limit as x goes to 0.5 minus with a minus sign, and the limit as x goes to 0.5 with a plus sign. So the minus sign means coming in from the left, like that. So you're imagining you're on this piece of the function, and the x values you want to get really close to 0.5 from the left. That's what the minus means. And what are the y values doing? So we did this in Desmos with the animation, but here is what it looks like on the picture. The points of the graph get closer and closer like this. And the y values, what are the y values doing? They're always 1 over here. So this is the limit as x is getting close to 0.5 from the left. It's always 1. It's 1, 1, 1, 1, 1. What are the y values doing? The y values are 1. And so this is because y values are always 1. On the other hand, completely different question, what is the limit from the right? Going to 0.5 from the right, and that is sort of going in like this. So the x values are going to be coming in towards 0.5 from the right side, and we're asking what does the function do? And you can follow along by taking the value of these points, and you can imagine it as an animation if you want, and ask what does the y values do as the x values get really close to 0.5. And you can see from the picture, they're going up, 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 up. They go up forever. There's no like limit they reach. They don't stop at 8 or something. They go up forever and ever. That's why this limit is infinity. And you could say because y values go up forever. So the limit from the right is infinity. The limit from the left is 1. That's really all of the interpretations of the picture. Next up, we have kind of two separate little things we're going to do. What is the two-sided limit coming in from either side? And as soon as the left limit and the right limit are not equal, this limit does not exist. So we saw that before. For the two-sided limit, both limits have to be equal. As soon as they're not equal, like in this case, 1 and infinity, not equal, it doesn't exist. So that's definitely true. It doesn't exist. Another way you could see that it doesn't exist is there are sequences that come in towards x equals 0.5. So if you have x values going in towards 0.5, there are sequences where the limit of the y value does not exist. What are some of those sequences? Well, anything that alternates left, right, left, right, left, right. So for example, a sequence like this one, then that one, then this one, then that one, then this one, then that one, then this one, then that one. This sequence, the x values are getting closer and closer to 0.5, but because we're doing this left, right, left, right, left, right thing, the limit does not exist for the y values. So that's why the limit doesn't exist, because the y values, there are some sequences where it never settles down. Another easy way to see it is to compare these two values, the limit from the left and the limit from the right. And because those are not equal, then the limit definitely does not exist. So let me get rid of that. That's a little bit more conceptual. If you just want the answer, it does not exist, and the practical way is to do these two limits. Last but not least, completely separate question, right? So far we've been talking about limits, the idea of getting close to. This last thing is a completely different question, which is, what is the value at exactly x equals 0.5? And this, I've said a number of times, is unrelated to the limits. This is like some other question. Unrelated to limits. F of 0.5, you just read it from the picture. In this case, we got a filled in dot right here, and a filled in dot means the y value is exactly 1. F of 0.5 equals 1. Because it's a filled in dot. If it was a not filled in dot, a circle, then it would be does not exist. It might have been a filled in dot at 4. That could have happened. Then the answer would have been 4. In this case, it's a filled in dot at y equals 1. So it's 1. That's this video. Okay, exercise 179.